Hello, and welcome to yet another Chi-Prime video where we solve a problem to prepare for the GMAT. As usual, I'll give you a second to pause the video and solve the problem on your own if you'd like, and then we can proceed to solve it together. Alright, so let's begin. Here we're given a question where there are four circles, A, B, C, and D, we're told, each with the same radius, capital R, and that all the four circles intersect in exactly one point. And the question is, which of the following five possibilities it has to be true if the premise of the problem holds. Now, in this kind of a question, it's typically useful to try to figure out if there's a way in which we can think about the conditions of the problem and see if it's in fact feasible. And then once we figured that out, it would be easier to determine which of the possibilities would be correct. So in this case, you have four circles that intersect in one point. Now, usually when we talk about circles intersecting in one point, and pardon my drawing here, but assume that they're tangential. So you have two circles, let's say A and B, and they're intersecting in one point. So they're essentially touching each other at that one point. And given that they have the same radius, they have to touch externally, right? But this distance between the centers is 2r. So this is a picture that comes to mind when we consider two circles. But we're given four circles. So on first glance, it looks like this is probably not going to happen, right? It doesn't look like it's possible to get four circles. But that's where we have to look at the options and see if there's any clues that we have. A, B, C, and D have the same center. Well, that's obviously not possible because if they're intersecting in exactly one point, then they can't have the same center, because if they have the same center and the same radius, then they intersect in essentially all the points are common to the circles. So this is not the right answer. A is definitely not the right answer. B says R is a prime number. It doesn't really matter what the radius R is. That does not govern whether or not the condition specified in the problem is true. So B is unlikely to be the right answer as well, so we can take that out. C looks very tempting. It says the problem statement is incorrect. At most, two circles with the same radius can intersect in exactly one point. So we park that on the side and we say, it looks like that might be true, but is there a different way in which we can construct the four circles such that the four circles of the same radius, capital R, all intersect in exactly one point? And then we look at option D, which says A, B, C, and D cannot be coplanar. And this actually gives us an idea. So consider, for example, and this is just one possibility, right? Example of a plane in which there are two circles A and B, like we have here, and they intersect in exactly one point, right? And then you can have another plane, pardon the drawing here, oops, where this plane is actually passing through this point of intersection. Let's call this point E, the point of intersection or tangency of circles A and B. You can have a plane either vertical or at some other angle to the original plane. Let's call the original plane P. P. Some other plane that's intersecting plane P at some angle within which you have two other circles of radius r. So for example, if this is plane P, in which you have two circles, A and B within, that are touching in one point, let's imagine these are on plane P, then if this is point E, you can have another plane that's passing through the point E, I apologize for that drawing. See if we can plane it up a little. Then we can have potentially another plane passing through the point E, imagine this is a straight line, such that the two circles C and D are on that other plane, and they also intersect at point E. So now you have four circles, no three of which are coplanar, and all four of the circles with the same radius are intersect in exactly one point. So that leads us to believe that it is in fact possible to have the conditions stated in the problem, and A, B, and C cannot be coplanar. Now there's a different way in which we can draw this picture also, and again, pardon my drawing skills, but for example, if you have A and B that are tangential, circles A and B are tangential at point E. You could also have a plane like this, where the plane is intersecting, passing through point E, and essentially the side view of this figure. But regardless, we see that there is at least one way in which we can meet the conditions of the problem where A, B, C, and D are not coplanar. Thank you for watching.